In this video, we are going to discuss about magnitude comparator. So, what is magnitude comparator is it is a combination circuit. It is a combination circuit which will compare two digital number. So, if it will be of one bit type, right? 2-bit, 4-bit comparator, 8-bit comparator, like that. It will goes on. Okay, so what it will do? So first let us discuss about 1-bit magnitude comparator. So it will compare A with B. Okay, so it will compare A with B. So if I compare A with B, it will be either these two are equal, or A is greater than B, or A is less than B, right? So if I take A as 0, B also 0, right? Since I have only this is one variable, it can take either the value as 0 or 1, right? Or it will be 1 and 0, or it will be 1 1. So these are my inputs, right? So these are my inputs and these are my outputs, right? So if I compare A, here A is equal to B, so I am giving the output as 1. So here also A is equal to B, so here also it is 1. Okay, for the rest of the value it is 0 0. Similarly, here you can see A is greater than B, because A value is 1 and B value is 0. So this is 1, the rest of the values are 0 0. Similarly, if you see here B value is 1 compared to A, it is less, right? So here this is 1 and the rest of the values are 0. Okay, so how to write A greater than B? A greater than B, that is equal to, you can write it as A. So let me take this one as F2. Okay, so this one as F2, F1, and this is F3. Okay, so F1, which is A greater than B, right? That is equal to summation M, summation N, for which value it is 1, for 2, right? So for 2 it is 1. So how to represent summation 2? Summation 2, so I can write as A B bar, right? A B bar, because A value is 1 and B value is B bar. Similarly, if I want to write it for F3, F3 is nothing but A less than B, that is equal to summation M, that is for 1 value it is 1. So how to write 1? A bar B, A bar B. Okay, similarly for F1. Okay, so F1, what is F1? F1 is A is equal to B, right? That is equal to summation M. So it is for 2 value it is 1. For what values? For what values of input it is 1? 0 and 3. So 0, 3. So how to represent 0? A bar B bar, A bar B bar, plus 3 is AB, AB. So formula for this one is A XNOR B. Okay, so this represent XNOR gate. So let me draw this one. Okay, so how to draw this is AB. Okay, this is AB. The ways can draw like this. Okay, this is how to draw A B bar. This is A B bar, right? This is A B bar. This becomes B bar, right? So if I give it to AND gate, it becomes A B bar. Similarly, if I want to get A bar B, this is A bar and this is B. Okay, so this is A bar B. That is equal, this is F3, this is your F2. Similarly, if I want to get AX nor B, okay, so this is your B bar and this is your A bar. So this is A bar, B bar, and I want to get AB, right? So this is your A and this is your B. Okay, then these two get added. So for I'm using um, OR gate. So this is your OR gate. OR gate, this is nothing but AND gate, and this is your NOT gate. Okay, so you will get A X NOR B. That is your F4. So this is how you have to draw the 1-bit magnitude comparator. Now let us go for the 2-bit magnitude comparator. So here let me take, this is A1 A0. A1 A0 is compared with B1 B0. So again, if I compare these two values, I will get A1 A0 is equal to B1 B0, or I can get A1 A0 is greater than B1 B0, or I can get A1 A0 is less than B1 B0. Okay, so now I substitute this values. So it ranges from 0 to 15 because it is 4-bit. I will get 2 power 4 is equal to 16-bit, which ranges from 0 to 15, right? So this is my 0. How to represent 1? So this is my 1, this is 2, this is 4, and this is 8. So how to represent 1? This is 1, so I'm giving 1. To represent 2, B1 is 2, so this is 0, 0, 0. How to represent 3? 1 plus 1. 2 plus 1 is 3, so this becomes 0, 0. So how to represent 4? A0 is 4, so this is 0, 0. How to represent 5? 0, 1, 0, 1. Right? How to represent 6? 0, 1, 1, 0. How to represent 7? 0, 1, 1, 1. How to represent 8? 1, 0, 0, 0. How to represent 9? 1. A1 is 1, B0 is 1. Okay. So A plus 1 is 9. How to represent 10? 1, 0, 1, 0. Next, how to represent 11? This is A1, A0, B1, B0. Okay, 1, 0, 1, 1. How to represent 12? 1, 1, 0, 0. 13, 1, 1, 0, 1. 14, 1, 1, 1, 0. 15, 1, 1, 1, 1. 8 plus 4 plus 2 plus 1 is 15. So if we compare, so for what values A1 and A0 is 0, this is also 0 and this is also 0. So it is 1. Similarly, you can see this is 0, 1 and this is 0, 1. So it is 1. And here you see 1, 0, 1, 0. So this is 1. And for 1, 1, that is 1. For the rest of the value, it is 0. Okay. Similarly, A1 is greater than A0. So for the rest of the value, it is 0, right? So here you can see A1 A0 is 0 and B1 B0 is 1. So B1 is greater than this, B1 B0 is greater than A1 A0. So I am giving this as 1. Similarly, since these two values are 0 0, so anyway this will be 1 1. Okay. And here you see A is 1 and B is 0. So A is greater than B. Similarly, this is 1 and this is 2, right? If we compare two bits, this is 2, this is 1. This is 2 and this is 1. So this is 1 and this is 2. So B1 is B1 B0 is greater than A1 A0. Again this is 3 and this is 1. Again this is 1 and this is 2 and this is 0. And if we see, this is 2 and this is 1. Since this is 2 bits, if it is 2 bit, A1 is taken as 2 and A0 is taken as 1. Okay. So this is 2 and this is 1. So A1 is greater than B1. Similar way, if we see B1 is greater. So the B1 B0 is greater, A1 A0 is greater. Okay. So how to write the equation? So if we see, whenever the two bits are equal, okay, you can write for what values under it is equal. So again I am taking this one as F1, F2 and F3. So if we take F1 is equal to, for what value it is 1, for what value it is 1, A1 A0, B1 B0 is 0 0 0, right? So I can write A1 A0, B1 B0. In other words, I can for this is 0, this is also 0. So again I can write B1 B0 part. So this is 1 0 and this is also 1 0. Again I can write A1 A0, B1 B0. This is 0 1, this is 0 1. Again I can write A1 B A0, B1 B0. Okay. In this I can take so if we see these two, okay, I can take A1 B1 common. If I take A1 B1 common, I will get A0 bar B0 bar plus A0 B0. From this two, if I take A1 B1 bar common, I will get A0 bar B0 bar from this one. And from this one, I will get A0 B0. Okay. So this I can write it as A1 B1 bar into A0 X0 B0. Similarly, A1 B1 can write A0 X0 B0. So if I take A0 X0 B0 common, I'll get A1 bar B1 bar plus A1 B1. So I can write it as A0 X0 B0 into A1 X0 B1. Okay. In similar way, I can write this F2. So F2 is equal to summation M. For what values it is 0. So for what value it is 1. So it is seen for 4, 8, 9, 12, 13, 14 it is 1. So I'm using K-map I'm going to solve. So I'm going to substitute how to represent 4. 0, 1, 0, 0 is 4, right? This is 8, 9, 10, 11, 12, 13, 14. Okay. So you can solve like this. So if I group this one, I will get A1. The common is A1. Here it is B1 bar. Okay. So this is my F2, right? So instead of grouping like this, okay. So if I write this one alone, I will get A1, A0, B1, B0 bar. Similarly, if I group only this one, I will get A1 bar A0, B1 bar B0. So in this, I can write A1 B1 bar plus, if I take here, you can see A is greater than B, right? So I will get A1 not, A1 not, if I take this B1 bar, right? A1 not, A not, B not bar common, I will get A1 X not B1. Okay. So similar way you can do it on your own, right? So similar way you find it for F3. So if you find it for F3, you will get A1 bar B1 plus A naught bar B naught into A1 X naught B1. So this is what you will get. So after that, let us just drawing the diagram, right? So if you draw the diagram, you will get the answer. So what is your F1? F1 is nothing but A1 X NOR X NOR. This is your X NOR gate with B1 B1 X NOR. So this is your F1. Okay, what's a bubble? So similarly, for this is your F1. What is F0? F2. F2 is A1 B1 bar. A1. So this is your A1 B1 bar, right? And you write A0 B0 bar. A0 A0 B0 bar. Then you have to multiply it with A1 B1 bar. A1 B1. A1 B1 is this one, right? So A1 B1. So you have to multiply with this one. Then you have to add it with, for addition, use OR gate to get F2. So similar way you do it for this is A0 bar B0, right? XOR with, so you multiply with this one, then you go to for F3, right? So this is nothing but A1 B1 bar, right? This has to be added with this one. So you make the connection. Okay. So for B1 bar, you have to connect it here, right? This is your B1 bar. A1, you have to connect it here. A0. This is your A0. And this is your B0 bar. A0 bar. This is your A0 bar. This is your B0. And this is your A1 bar. And this is your B1. So if you see a naught bar, it is multiply with this one and get added with this one to get the answer. So I hope this video is useful for you. Thank you very much for listening.